Today's lesson 3.1, Solve linear systems by graphing. Systems of equations are more than one equation that share the same solution. Often they involve more than one variable. In order to solve them, you need as many equations as there are variables. For example, this system has two equations and two variables, x and y. Solutions to the systems are an ordered pair that works in both equations. If the ordered pair works in both equations, that means that the graph must go through that point. So, the solutions are where the graphs intersect. Today we're going to solve by graphing. So, graph both equations on the same graph and find where they intersect. We have several different types of solutions. First of all, there's many solutions. That's when both lines are the same graph. Many solutions is consistent, which means there's at least one solution, and dependent, meaning the value of y depends on the value of x. Another option is one solution, where they intersect at a single point. It's called consistent, means there's a solution, and independent. The value of y does not depend on which x we choose. Our other option is no solution. That's if we have parallel lines, and we call that inconsistent. So let's try some examples. To solve by graphing, start by solving both equations for y. So take the first equation, solve it for y, so you'll subtract 3x and then divide by 2. If you compare this to y equals mx plus b, the y-intercept would be the -2 and the slope is -3/2. Graph it by plotting the y-intercept and then following the slope, down 3 and over 2. Take your next equation and solve it for y. So subtract x and divide by 3. The y-intercept would be 1/3. The slope would be -1/3. Graph it by plotting the y-intercept at 1/3 and then following the slope, down 1 and over 3. The point where the lines intersect is the solution. So you can see we have one solution. By looking at the graph, it appears to be -2, 1. Since there's one solution, the solution is consistent and independent. Let's try another. Take your first equation and solve it for y. First equation, subtract 3x, divide by -2. So the y-intercept is -5 and the slope is 3/2. Graph it by plotting the y-intercept and following the slope up 3 and over 2. Take your next equation and solve it for y. Subtract the 3x, divide by -2. So the y-intercept is -1, and the slope is 3/2. Start by plotting the y-intercept and following the slope up 3 and over 2. Where the lines intersect is the solution, but as you can see, they're parallel. They don't intersect, so there's no solution, which means it is inconsistent. Let's try another. Start by solving the equations for y again. Take the first equation, solve it for y by subtracting the 2x. The slope is -2. The y-intercept is 1. Start by graphing the y-intercept of 1 and following the slope down 2 and over 1. Repeat for the second equation. Since it's negative 4x, so add 4x, then divide by negative 2. So the y-intercept is 1, the slope is negative 2. Graph it by plotting the y-intercept and following the slope down 2 and over 1. Where the lines intersect is a solution. Since they're the same line, they're always intersecting. So it's infinitely many solutions, which is consistent and dependent. Now let's try a word problem. A soccer league offers 2 options for membership plans. Option A is a $10 initial fee and $5 for each game played. Option B is $10 for each game played with no initial fee. How many games must you play for both plans to be the same? So we're going to start by writing an equation for each plan. Start with plan A. The cost is $40 plus $5 for each game. So our cost, y, would be 5 times the number of games, which is x, plus the $40 initial fee. Graph it by plotting the y-intercept, 40, and following our slope of 5 over 1. Notice I'm not going up 5 squares and over 1 square, because in the y-axis each square is 10, so I'm actually going up half of a square, which is 5, and over 1. Plan B is $10 for each game. So our cost y is just going to be $10 times the number of games. The y-intercept is 0, and the slope is 10 over 1. So I start at 0, we go up 10, which is 1 square, and over 1. Where the lines intersect is the solution, and you can see that that point is 880, which means it's 8 games and $80. The question is just asking for games, so you must play 8 games for both plans to be the same cost. And here is your assignment.